So John, can't share my screen error. I thought I fixed this. Maybe you can share.
Okay, yeah, I can share.
Yeah, this is a Mac OS update. I'm not really sure what the deal was. Sorry, folks. Lots of updates lately. Thanks, Robert. So Nate, I guess you're up first. Real quick, I moved the roadmap continuation and the environments retrospective to the next meeting. The meeting after that, a lot of folks will be at KubeCon. So we may cancel or we may have it. I don't know. I won't be here. So if John or Martin want to have it, that's fine. But for the 13th, I'd definitely like to get the roadmap discussion in and the retrospective done. But this meeting kind of filled up with the mesh federation work, which I think is great. So if folks could first sign in with their attendee names, and then maybe Nathan, you can kick us off with what you've got there.
Sure, 1 second. Oh, I think, John, because you're presenting, do you want to just present that doc? Yeah, cool.
Yep.
Yeah, okay. So I shared this out maybe a week or two ago. Been a lot of activity on it. Basically, we just wanted to kind of take a step back and start with kind of like a more or less kind of like a toy basic multi-mesh deployment. I did it in RFC form. I'm not sure I necessarily followed the intended, I guess, kind of like formatting for it. I think there might be a little bit too much detail for it, so we can probably clean that up. But fundamentally, I just wanted to kind of like say like in effectively a perfect world, where we can simplify the problem as much as possible. Get some of the basic nuts and bolts together for how to actually make two meshes talk. So yeah, so I don't know if we want to go through the whole thing here. I guess we can kind of scroll down to the requirements of the system that we were kind of specking out here. This can probably be the focal point for this discussion. So basically, we at a minimum, we want to support HTTP and TCP services. HTTP is obviously a lot simpler, but to be useful, we're probably going to want to support both. So we are using, just kind of assuming that both meshes already have unique domain suffixes so that we kind of like avoid conflicting names when addressing services in the other cluster. Same thing with trust domain that and in fact we actually say that the trust domain and the domain suffix match just for simplicity. So basically everything has already been configured properly and both meshes are just ready to federate. So the one contentious issue is the next bullet where we're talking about effectively the services in both clusters are publicly resolvable via DNS. The problem gets a little bit more complicated when we actually want to deal with like each mesh kind of like having its own internal DNS and having to create entries and configure both sides to be able to talk. For the simplistic toy model, we just want to kind of get rid of that problem and just say that okay, the services are already publicly addressable, to kind of simplify the problem a bit.
So Nate, real quick,
yeah, well, sure.
Real quick, so service discovery is always a challenge with this multi-cluster work. We get wrapped around the axle on service discovery every single time. I think one of the issues that I see with the service discovery using DNS is that you leak information. I don't know how important or not important that problem is. I mean, most of the multi-mesh cases I've heard of involve security constraints, right? That they're driven by the need for higher security levels. Sure. So what's your thought on that leakage? Just kind of off the top of your head, the leaking of that information there. DNS?
Again, I think what I'm trying to do here is not necessarily identify a system that is necessarily going to meet a broad set of requirements. What I'm trying to identify here is a way to simplify the problem so that we can start rationalizing about federation and starting to kind of like deal with the fundamental issues and get those out of the way, and then kind of like layer more complex and more secure solutions on top of that. Does that make sense? Go ahead,
can we remove the word publicly? All services being federated are resolvable via DNS, and that addresses Steve's comment, because DNS doesn't have to be public. It can be internal DNS. Most companies have split DNS.
So one thing about the system requirements, I think this is great that we're focusing on requirements for the first time ever in the environments working group. That's huge. But yeah, the publicly addressable, that almost seems like an implementation versus a requirement. I don't know. It's subtle. I think
resolvable by DNS is coming from networking. I mean, you cannot have networking. You cannot do anything if you cannot resolve the names.
I agree.
So somehow all services need to be resolvable somehow. Publicly, I agree, it's not necessary.
Okay. Yeah. I can certainly remove public.
Custom has a button there to go on mute. That's awesome. I need one of those. Anyway, sorry. Go ahead, Nate.
Okay.
I digress there.
Yeah, I mean that's fine. We can remove publicly if that helps get us past that for now. I have no issue with that. The rest of these, are, a lot of them are basically things work, right? Like telemetry works. You can call into the other mesh, and you get telemetry for that call. So the next one is basically authentication. So you can authenticate all the identities from the other mesh. Policy can be written against all the identities from the other mesh. And by default, you'll reject all the identities from the other mesh. So you basically have to opt in on a per workload basis or per service basis. So service discovery works. Obviously, that's simplified with just the fact that everything's resolvable via DNS anyway. You can apply traffic management rules like traffic splitting. Secure naming works across the mesh, and we can reject impersonation.
So real quick on the traffic splitting, there's this version saying for subsets. Do you plan to have that as a requirement, the subsets work?
I don't know if we want to take that on for now. Costin, do you have any thoughts on that?
Can you repeat the question?
Sure, subsets and traffic management and this work.
Yeah, they definitely need to be supported somehow, no?
Yeah, so should that be a requirement was the question. And I think Nate wasn't sure. Nathan wasn't
implicit.
Sure. Implicit, yeah, I don't know if it's implicit. It probably should be spelled out.
Yeah, we should probably spell it out.
Well, technically, not all subsets need to be supported because, again, DNS, in order to use a subset, well, actually, no, they have to be supported. Yeah, absolutely. A lot of features depend on that.
I mean, Istio is not really functional without subsets, but it's functional, not super functional. So, I don't know. I think it should be probably a separate,
let's add them.
Separate requirement or part of this super requirement.
Yeah, I think that's fair.
And the reject impersonation part, I guess we'll have to get to how, and I'd really like to do that in a separate document, but I think we really need to focus on making sure rejecting impersonation is a thing and actually viable. So we don't have to do that now, but
I don't think we need to spell it out explicitly because it's already, we are saying trust domain, we need identity passing. That implies by definition that you cannot impersonate.
Yeah, well, it's already specified here as a separate item, which is fine. I think that's good that we're calling rejecting impersonation out as something that needs to be focused on. All I'm saying is maybe in a future meeting we can get to how that's going to work correctly, because I think there's a lot of challenges with that personally.
I have a question about the traffic splitting. Is that going to be possible to apply that rule on either mesh or only on the receiving mesh?
It should be on both meshes. I mean, why does it matter?
Because it requires the subsets to be sort of transported.
Yes.
Okay.
I mean, the user doesn't really care how it is implemented. I mean, the requirement is that it is supported. It could be implemented on client, it could be implemented on server. I don't think we need to tie our hands.
But actually, I think it's a requirement that the proper behavior of a server can't be determined by what the client does. Right? We don't trust the thing on the other end. So you can't trust client-side load balancing in this topology or stuff of that nature. Right?
I think my question was about the visibility of the subset. So I want to send 90% to version 2. And how do I know what the versions are? They're not in DNS. Or if they are in DNS, are they put on the front of the thing? So it'd be like v2.details.example.com.
So maybe it's too detailed implementation, but in order to implement this, I presume that we'll need to exchange endpoint information across meshes. I mean, the meshes that are collaborating, presumably they will have load information and other access. We may restrict. I mean, I don't know if what Mariano was saying is right. I mean, we in some cases we may want to be paranoid and not trust at all the client, but in some cases we want the client to take advantage of additional information for better load balancing, for example.
See, my thought is that if we want to exchange that information, we're doing multi-cluster. That multi-mesh has different trust domain on both sides.
Exactly. That's my point.
And so it's a valid point.
We should take a default position here that the only thing that we allow the two sides to do is to have trusted identities. So local in-cluster policies can be applied to things coming from the outside. Beyond that, they should be separate.
But that's really the internet. We are not talking about multi-mesh. I mean, there is multi-cluster where they share the same naming. There is multi-mesh, and then there is the internet. What is the difference between internet and what you describe here? What I
described here is that individual workloads in a source cluster I can apply policies on those workloads on the destination cluster. So
you can do that on the internet.
If I have two companies hooked together, I can apply policies on particular workloads coming from the other company, not just everything from VMware.com has a particular policy. Right?
But you can do that already. I mean, that's how service works. I mean, anything with OpenID Connect or with identity works perfectly fine over the internet. There is nothing Istio than needed in this case. So I think this multi-mesh provides some extra benefits compared with just using internet, like a load balancer and the existing techniques that work on internet. We can provide additional information for better load balancing. We can provide additional information for client-side decisions. If you have multi-region, multi-whatever, you can do this without relying on DNS for regionality.
So do you think there's so I can see where this is a valuable benefit for like two parts of a company that want to join two meshes together. Do you think these are reasonable things to do when you're talking to a different company?
Let me give you an example. Let's say Google, take one popular service from Google that is multi-region, multi-cluster. Let's say that service starts to expose an XDS or MCP feed with detailed information about endpoints. We are not revealing any secret information because reality, the information is available by querying DNS because GCLB and load balancer is providing similar information. But clients will be able at client side to make better decision about, they have load info, they know the region and locality. They can make much better decision and save latency without exposing any secret information.
So when you say exposing endpoints, I mean, that wasn't the idea of multi-mesh to go through gateways? Are you saying that for every endpoint that you expose, you'd also expose a gateway?
You may go through gateway, you may not. I don't know if it's necessarily required in any way to go through gateway, but the idea is that you even through gateway, you will still have some information about, you have a gateway in US, one in EU, and you have relative loads and information about, what versions are running in each region and what capacity it is, and this kind of stuff that you can use to optimize traffic. Otherwise, you have internet. Internet is already providing all the features for completely disjoint, foo.com and for.com talking together. I don't know. That's my opinion. I mean, I think we can provide more value, and we should distinguish ourselves from standard internet.
So I guess I see the benefit if I don't want the two worlds to mingle their policy space. Right? One company applies its own policies, the other company applies its own policies. It can't be the case where if Microsoft is joining a mesh to IBM, that if Google is joining a mesh to IBM, that Google's fate depends on IBM doing something. But if IBM can leverage some state provided by Google to do better load balancing on its side without revealing any secrets, I think that's totally reasonable. Yeah, so that we should leverage. It just can't be a correctness dependency. Like the server can't depend on the client's behavior.
So this is where I get stuck with the subsets, right? Because I start to think about this and traffic routing and subsets, and I think the client is going to know, the server is going to be dependent on the client in this scenario, and there's going to have to be an exchange of information. Is that not correct?
Well, the server will expose additional information to clients, so client can have more information, but all policies will still be server side. I mean, that's what we are doing today. It doesn't matter what kind of mesh it is.
Yeah, but you're going to have disjoint policies.
You have them today. I mean, even with single cluster, you can have client can be override. Destination ruler with sidecar can override the settings on the server side.
Okay, so you just said the client can override the server side.
Can override for destination rule. I mean, whatever is in destination rule can be overridden by the client. I mean, he can choose to use different timeouts, different other things on client side, and you cannot enforce that.
So I think there's a challenge here, and that's that we don't expose security vulnerabilities in this model.
Oh no, all security is server side, so there is nothing the client can do about security.
I get that TLS is going to be secure on the server side, but the mesh routing may not be, right? In your model, or in the model that's proposed.
But
no,
there is nothing you can do about it. I mean, on the internet or wherever, a client can do whatever it chooses. You cannot force it to route in a particular way. You can provide information to better route, but in the end, it's client controlled.
So let me give you an example. Let's say I'm a client and I'm attacking your server, and I say, please follow this route through your server so I can make an attack. That's different from the internet, where there is no please follow route to this server because everything's blocked, right?
Agreed, but that's where the it's federation is not. That's one of the difference between federation and non-federation. IBM attacking Google, if they are federated, yes, that's possible. It opens this door, but then you don't federate anymore.
So I think we need to get to a model where an attack isn't possible.
I don't think that's possible. I wish, but
okay.
I mean, you can have an attack within the mesh itself, right?
Yeah. Right. You can today, but you trust that you trust everybody in that mesh.
Yeah.
Today we trust everybody in the mesh. When you're talking about joining two meshes, you're talking about two parties that may not trust each other.
Yeah.
But they want to share one specific service, not the whole mesh.
Yeah. So let's imagine in the real world, if we wanted to do this at Google, we'd have to jump through hoops and prove that this is a limited liability and a whole bunch of stuff.
I think it's not secret that I think we're already doing it in Google, for example, for messaging systems, or we did in the past where we had federation for I don't remember, Hangouts and other application, or for the SIP and voice stuff. I mean, it's very common to have federation at this level, and usually it does involve this kind of additional sharing of information.
So Nathan, I think the document needs particular attention to state sharing between the two meshes, so we understand exactly what gets leaked and what is the client's responsibility, what is the server's responsibility, Otherwise, we don't know exactly what's going on.
That sounds great. I would really like to see that as well.
And it's not specific to this document. I mean, some things are across Istio in general, namespaces even. But yeah, let's start with this doc.
So Nathan, can you tackle that? Is that
Yeah, makes sense.
clear? Okay, cool. So I think we can move on from that rat hole a little bit. Thanks, Martin, for getting us out of there.
To be honest, I think that's probably a good point to stop with this doc for today, because I think a lot of the rest of it kind of goes into more or less a bit of implementation that probably shouldn't be in this doc anyway. So I think that really should be the focus of today's discussion there.
So I guess there were two things that were added. I don't know if you added them. They look like question marks, as in they were added requirements: boundary protection and location transparency. Who added those? Did you add those, Nathan?
It's me. It's Vadim. I added them.
So, I mean, do you guys want to talk a little bit about that or not? I don't want to burn up the whole schedule because we've got a lot of agenda items, but if we could talk for 5 minutes on these two items specifically. I want to make sure that the requirements we have are meeting people's needs, and if they're not, we need to kind of settle that out, I think, a bit. So one of you go, Vadim or Nathan. Vadim, why don't you go since you wrote them down first?
Yeah, so boundary protection actually means that you protect your mesh at the boundary. Okay, that means at the ingress gateways in our case. Okay, so you do not let your traffic inside and then apply security policies. You apply security policies at the gateway. Okay, this is the first part, and the second part is you, for example, do not leak information about your endpoints, about your IPs outside of your mesh. Okay, this is the second part of boundary protection. And look, yes. Mm-hmm.
Are you saying boundary protection is mandatory or it's optional? People can choose to use have boundary protection and can choose to have.
Yeah, so this is why I put a question mark here. So we should decide: do we want to support it? Do we want to support it in an optional way? So
but again, this document isn't trying to define the requirements for all of multi-mesh. It's trying to define requirements for a very specific minimalist system. So I think if it is optional, we should probably just get rid of it from this particular document.
Well, I think it's an important use case, and we should. I think it's a good point to have a requirement to support boundary protection.
Yeah, I want to try to talk about that a little bit during my piece at the end, because I have some notes about the different kinds of data plane security.
Yeah, I think it's useful to list the optional requirement here, not to say this is other things we will work on day one, but just to, as we build the mandatory portion of the system, we have in mind we want to be able to scale up to the optional, because you don't want one day, because we want to support boundary protection and we rewrite everything we have already been built for multi-mesh.
Right on, Lynn. I like it. So location transparency, maybe we can move to that one, Vadim.
Mm-hmm. Yeah, and just to mention, the boundary protection is required by multiple compliance security standards, okay, like PCI DSS and others. And location transparency means that you can call a service without knowing in which mesh it is exactly located, okay? And this way you can migrate services from one mesh to another, and even maybe between local and remote meshes, okay, without changing the application code. So the application code continues to write in the same way, whether your service is located locally, whether it is located in service one, or in mesh one, or in mesh two.
So can this be achieved strictly by messing around with service entries?
Yes, it could be.
I think it's too dangerous, and I mean, it violates all the requirements above, because if the idea is that we have distinct domain names, I mean, distinct suffix, distinct trust domains, that makes this requirement completely impossible and incompatible with what we discussed before. It's perfectly possible to do it in a multi-cluster, in a single mesh multi-cluster, because you have identity. But again, naming, you cannot write a policy if a particular service can move from one trust domain to another or from one name to another. There is no sane way to do it. So I think we should be explicit that this is not supported and not possible across meshes.
Okay, and it's fine that we document what we do not support explicitly.
We can explain why we cannot support it, because it's it's no physical way to do it.
Yeah, I think
Okay.
location transparency is tricky because using our example IBM.com, if I expose bookingfo.ibm.com, and then if you expose some other things, it's going to be specific to your domain name plus your service name. So I can't imagine we still call bookingfo.ibm.com when that service moved to Google.
And certificates and policies and everything else will be screwed. So that's really.
So this seems like a tough requirement, but Dean, why did you add this in? I'm just out of curiosity. I'm trying to understand what the rationale for this. I get that there's value in being able to move services around. I hear that all the time. I want to move from X to Y cloud, but how did you see this working? Not maybe how's the wrong question. I shouldn't even ask how, but why? Maybe why?
Yeah, I think in the multi-cloud world that you can have multiple clusters, multiple clouds on premise, on clouds of different cloud providers, I think this could be valuable. And then you will be able to migrate between multiple clouds and on premise.
Vadim, to be clear, this is perfectly possible what you describe, because the idea is that you have on-prem multiple clouds, but they are on the same mesh. So they have the same trust domain and identity namespace. So as long as you can maintain that 10 clusters are on the same trust domain, consistent namings, then location transparency is possible. It's only when you want to switch between two meshes with different suffix and trust domains that is problematic.
Yeah, I see, but I think it's a valid requirement, and maybe we can document that we do not support it. Okay, it's also okay. So let's clarify what we support and what we do not support. The use case here is multi-cloud, okay, and the ability to migrate transparently services between multiple vendor providers. And on
so let's document that we support it within each mesh. So each mesh can has location transparency, but location transparency doesn't work across distinct trust domains.
So, so the objective here is that you can move you have a service that's consuming service A that's consuming service B. Service B moved to somewhere else, and you don't want to change the source code for service A.
Right.
So can we provide an aliasing or indirection mechanism outside the code to do this? That doesn't seem like an impossible task, does it?
Well, security policies, TLS verification, it's extremely complex and extremely easy to mess up. And is it worth it? Because the same requirement can be met by moving to a different cluster in the same naming.
Yeah, I think the best practice for that exact scenario is single mesh. Period. I don't see why we even need to, call this out in a multi-mesh doc.
But that's the thing.
So as long as you keep the name,
it is a multi-mesh scenario. Again, I've got Google talking to IBM, and I reference a service by name, and that IBM decides, we need to move this to a different system, and I don't want to change my application code to talk to that other system.
But that's not what the scenario that was.
You change it.
That's not the scenario that was called out. The scenario that was called out is it's your system, your company system, but you've got multiple vendors. You got some services running on vendor A, some services running on vendor B, but it's still one mesh. That's the scenario.
Oh well, then that's clearly not a multi-mesh case.
Exactly. So that was my argument for that. It shouldn't even be in this document.
Yeah, and even Martin, in your scenario, if IBM decides to move this particular service, let's say bookinfo.ibm.com to on-prem or different region, it would be the company's responsibility to still maintain that API as per the contract. So regardless where it's running, it will be whoever provides bookinfo.ibm.com is responsible for keep that up running.
Okay, that's fair. So it's a server-side concern, not a client-side concern.
So I guess the question is there any need for the server side to change anything? I don't know. How to express this. It seemed like the security the certificates would be a problem, right? If you're moving from A to B, how do you do that? I guess we shouldn't get into how, but Vadim, maybe you could flesh this out a little bit more so we understand what you mean here, because I think we're struggling at what the objective is of this exactly.
Okay, will do.
Good. Okay.
I'm not really sure we need to. I think the objective was pretty clear. It was one company that has services running on multiple vendors, right? I think that was pretty clear. I don't think we really need more discussion.
Vadim, is that correct? If that's accurate, then yeah, we can close the discussion.
Yeah, I think so. Yes.
So we can remove this requirement then. I just don't want to lose stuff that seems valuable.
Yeah, let's just state that we do not support it.
Okay, good.
We support it within each individual mesh, but we don't support it across namespaces. So you can still do location transplanted.
Okay, good. Okay, let's move on. Vadim or Ed, I don't know which one you want to go first. I think Vadim, I don't know if you want to talk about your work next, or Ed, you guys flip a coin and let me know.
Yes, let me just present it shortly.
Sure, okay.
Okay, so here's my, let's say, implementation of Mesh Federation. And let me present it.
Your screen dropped off there.
Oh, what happened? So I can't present for some reason. But anyway, you have the link, and the killer argument for my implementation is that it already works, okay? So you can show it to your clients, your partners, okay? And maybe they will actually be happy with my implementation already, okay? And it provides boundary protection, it provides location transparency, and it is what Kostin calls internet style. Okay, and it is based on standard Istio installations. Okay, standard Istio mechanisms. You don't need any special DNS, so you just uses, for example, Kubernetes service entries. It uses Kubernetes external name services, Kubernetes services. It uses Istio service entries. Virtual services, gateways, and so on, okay? And you can, as I said, you can configure it today, and Ed and Muhammad from IBM, they are working on automation. So I would encourage you to read this, to just take a look at this implementation, to read my blog post about boundary protection, okay, which is required for multiple compliance and security standards, and consider it, yes.
Well, given that it's the internet style from Kostin's comment from before, what's better than pure internet? Like, what makes this mesh federation as opposed to just two separate meshes?
Okay, what makes it mesh federation is that you kind of federate the gateways. Okay, so you use certificates, okay, with common root certificate, and you inject these certificates into gateways. So you have egress gateway and you have ingress gateway, and these gateways in two meshes, they trust each other. And then you expose your services via ingress gateway in exposing mesh, and then you configure your traffic to go to the exposing cluster, okay, to exposing mesh, through your egress gateway. So you set this trust between two gateways only. You do not have to set trust between, all the workloads. Okay, so these two gateways trust each other, and then you specify your policies in terms of like gateways, for example, which gateway, okay, which cluster, which specifically gateway can talk to your specific services. So you have, for example, you expose services A and B, and you can state that service A can be consumed by cluster 1 and 2, and service B can be consumed by cluster 3 and 4. So this limited trust between gateways, this is what makes it federation. So the gateways trust each other.
I think there is a very easy way to distinguish between cases, because one way to think about it is what happens if you remove mesh from one of the clusters from one side. If you just use a standard web Nginx with some certificate with some policies, everything will work exactly the same. I mean, there is nothing that different from what you describe with two meshes, and just having Nginx and a configuration in one side and having a mesh on the other side, or having just Nginx on both sides. So it's really what any gateway. So it's not, there is nothing mesh specific in this scenario. You can provision certificates on any internet server. It's standard API management in both ends.
Yeah, I would call it's not an implementation. It's kind of set of design patterns. Okay, so like in a programming language, you can have a design pattern. You do not change the language. Okay, you specify in a pattern how you use the existing constructs of the language. You know, inheritance, composition, and so on. And here, this let's say this repository, okay, is a set of patterns how you can connect to meshes. Okay. And specify RBAC policies using existing Istio and Kubernetes mechanisms.
But to Carsten's point, then I think that's either too constraining or misleading. This is about consuming services on the internet and exposing services to the internet.
Right, and together you have this
one side and
federation.
the other side is a mesh, is a secondary thing, right?
Yes, but together, you know, you have this pattern of federation.
But Vadim, I like your point. I think it's wonderful to have some patterns. That's wonderful. But I think if you take your document and split it in two, we have patterns for exposing services on the internet from one mesh, pattern for consuming services on the internet or from wherever in the other side, and they can work together, and then you have two meshes that are talk with each other. But I think both ends of your design can be used independently of each other.
Yes, exactly.
They can be used independently, but they can also work together with some clever stuff Mohammed and I are trying to do.
Absolutely.
I'm going to try to sketch a little bit of that in a few minutes.
Yes, and just to finish, it works for HTTP, for TLS, and for TCP. And again, it's like taking Istio ingress patterns, taking Istio egress control patterns, putting them together, and you have mesh federation that works already today without any change to the Istio code. So Ed, please present.
I have a question. So the TLS terminated at the gateway.
Right.
Okay.
So Ed, please go ahead.
I would love to present. I'm getting some new security things from the system. It would be wonderful if John could bring up my slides.
Yeah, I can do that.
This is the first time I've tried to present since I got Catalina. So the link should have all the stuff I want to say. This is some user experience stuff that I got working with Vadim's style and working with Mohammed on doing it. Next slide. So the first slide talks about the difference between the different styles of communication. You may remember me charging through the networking meeting last year with this WRF proposal with pass-through gateways. I wrote this slide to talk about the different data plane styles that I saw in the different proposals. And I tried to put the pros and cons together so that you could get a sense of the benefits of each thing. I like a lot of the stuff that Nathan is showing, but I like also some of the stuff that Vadim is showing. And I encourage you to, first, if I got your cons or pros wrong, Nathan, I would love to hear about it. But I think that users are going to want to make these changes independently, depending on the kind of relationship they want to be in with their vendors and their other multi-mesh partners. So there's not a lot to say here unless you want me to go through each one, which I don't want to do. I sort of have three concepts, and I want to show the next concept. Can you switch to the next slide? So what I noticed was that joining a group is pretty rare. It's not the case that we're setting up hundreds of clusters and they're all going to join together like in a multi-cluster situation. It's something that you do because you're in a special relationship for your bank, processing some data for them. And there's often a lot of manual steps. There's different trust relationships. I might have to do one kind of communication with my bank, which has a big security thing, which has a big manual process, and a different style of multi-mesh communication with, say, a vendor who's providing me with some cloud storage. So what I've been trying to do is to take those styles I showed before, and maybe some others, and create a CRD called a Meshfed Config that sort of describes the kind of relationship that I want to participate in. So I'm saying for the blue network, you know, I want to use an egress and an ingress. I want to use the boundary protection style from Vadim's blog article. I want a secret that is used by all of the blue as their certificates. With the Meshfed config, maybe it's different. Maybe I want to use Nathan's style with sort of the trust domain stuff that he has. So I want to encourage everyone to think about this possibility. These M1, this mesh, you know, needs to talk to M2 and it needs to talk to M4, but these other ones don't need to talk to each other. And exposing everything publicly on DNS it seemed like a problem. We also really liked the idea when we were designing this of aliases. So we don't want to just say, I'm going to export details. We want to say, I want to export my details as details. We want to use that to hide the internals of our system from our public contract that we enter with the other people that we want to have a mesh with.
So that's the main concern with the exposing everything over DNS?
So the concern with DNS is first that there's not a lot of fine-grained nature. I'm going to talk about how I think exposure should be done in terms of how you find your partners in a moment. But it was unclear to me, you know, how subsets were supposed to match. I did some junk where I, you know, expose you know, reviews v2 as reviews-v2.example.com or v2.reviews.example.com, all kinds of stuff. It didn't map well. So what we wanted to do was, first we wanted to keep the user, keep the administrator of the server cluster from having to use names that his clients expected. Remember, he's going to be wanting to do rolling updates, and he's going to be wanting to bring in new versions. So he might upgrade from version 9000 to 9001, but the client is upgrading from version 2019 to version 2020. There's so many differences in terms of how they want to talk because they don't want to share their internals with each other. So this slide is about several user requirements that I perceive. One is being able to join multiple groups with different styles and being able to do aliases, and then wanting to be able to use the CRD to document to help you with tooling, the kind of tooling that Mohammed and I are hopefully going to show in 2 or 4 weeks on one of these calls. Any questions about this? Let's go to the next slide. Can you switch me, John? So instead of a DNS, I was thinking that it would be really wonderful if every ingress could support some kind of Swagger directory. We know all of the services that we're exposing. We could annotate or put into the expose to or to an exposure CRD if we want it, how we want it to appear in this directory, or if we want it to appear at all. And the idea is that every ingress would just list the services that were there. This makes it really easy to debug problems like should I be able to see these services? Just getting a list of what's there. We could easily generate this, and it seems more in the spirit of what we want than DNS. It also deals with the stuff that Vadim is doing that he didn't talk about. To get some of the security stuff he's doing with RBAC and things, he's translating some of the pod and service names into these paths. And it helps you to sort of discover that because it's hard to get right. It lets you use sort of Swagger tooling to help make clients. So we think there's a lot of good stuff here. I also think that something like this would help with location transparency. You could imagine like a redirect or something in either a Swagger or similar directory. So you could sort of say, you know, you've been calling me, and suddenly you're getting, you know, redirect errors, or you're getting errors. I'm imagining agents running on both ends. One agent is polling this, every 15 seconds and seeing if new services have been added, making the right service entries and virtual services to sort of expose the stuff that is in this directory into Istio resources, like on the client side. So I think this could help with some of that problem.
Yeah, so it's again like patterns, internet style patterns. Okay, you have redirect, you have Swagger, and so on.
I think this could give somebody a real smooth experience. So you do some manual stuff to share a secret, like you carry it over on a SIM card to somebody, and then they create a secret with it, create this CRD that says I want to be in a relationship. The first time that comes up, it makes the gateways. That's the code Mohammed and I have written. Then it, once these gateways are up, it starts polling this directory and creating service entries and virtual services to sort of help you out with that. So it makes the experience really smooth. It gives you the feel of multi-cluster without sharing so much of the secrets, and it gives you sort of an Istio-like experience as much as it can without knowing anything about the other mesh other than what's here in this directory.
So this would require effectively a multi-mesh controller.
Right. So you're going to want a controller for, first you want a controller for this new CRDs that we have or annotations. You're going to want maybe another controller for if you want to use this directory thing and get automatic stuff. It would be something you'd only use if you were doing multi-mesh, and it would be possible that it would be either part of Istio or a different thing. The implementation that Mohammed and I have translates from our new stuff into Istio rules without any changes to pilot. So in that way, there's nothing really needed to be added to Istio, although you could imagine this would be a great thing to add as an add-on to Istio in the same way we add Prometheus or something. So hopefully I'll have a demo to give in 2 or 4 weeks, and hopefully we can see. But currently, our implementation is based on the Vadim style. It would be, but we're not doing that. Our sort of controller has a bunch of to-dos for sort of direct networking on a flat network and with no security, and also for the style we saw earlier today with the pass-throughs. It would be great to somehow link up those codes. So if you have an implementation that you can give us early access to, Nathan, we could maybe figure out how to see how congruent they were.
No, there's nothing at this point. So yeah, be interested to see what you have.
Right, so this is on Box. I don't know how to leave comments on there, but maybe we can make a Google Doc and I can paste these as pictures and get some comments on these 3 concepts from Tony.
Okay, I think Tao, you're up next. Are you here to talk about this?
Yeah, I'm here. And we only have 7 minutes, and this talk is about like a call for comments about how multi-cluster COI works with operator. And what I noticed in the previous multi-cluster doc is we don't have a clear agreement about how multi-cluster command, COI command works with the operator. And both multi-cluster COI and operator are independent work and created simultaneously. And so what I propose here is we should have some agreement between multi-cluster COI and the operator. And we should have a talk about the recommended deployment model for the user to use it to deploy multi-cluster into different clusters. Also have operator inside. So can you scroll down to the next one, next section? So the requirement here is about, the first thing is the manifest generation. It's like shared responsibility between multi-cluster CLI and operator. For multi-cluster CLI, which is created by Jason Young, it will take for now it will take values API and output. It will take the values API and the cluster list as input, and output the values API, which I suggest we should change it into a Istio control plan YAML. And the operator will generate the manifest by taking the input as a Istio control plan YAML and output the manifest for the Kubernetes. So the problem here is we don't have a clear agreement between multi-cluster and operator. How do they talk with each other? And in this talk, I propose that we should have an agreement that the multi-cluster command should output something can be piped into operator and can be used directly without any change. And the second topic is about the resource ownership. And for now, there's multiple controller works simultaneously created by different groups. The first one is the operator controller. The second one is security and certificate manager. And for operator, the problem is we are not sure which resource is managed by some controller. When we get an updated manifest or input the Istio control plan YAML, should we modify some resources is not owned by the operator itself, or should it be changed by other or owned by other controllers? And the proposal here is the operator should focus on in-cluster resource management and installation, and all the resource created by operator, including the configurations generated by multi-cluster, should be managed by operator itself, and only focus on in-cluster resource, not the cross-cluster, multi-cluster resources. And another interesting thing is MultiCloud created an operator, which will take care all the resources cross clusters. Like if you create an operator in one cluster with multi-cluster configuration, the MultiCloud operator will create all the Istio in different clusters. So in this talk, I propose that we shouldn't do that, and we should leave that work to the CI/CD system. And the last thing is about the cross-cluster identity and access. That is, we already have some multi-cluster command to create secret between different clusters, but we don't have agreement between those two multi-cluster and operators to say operators shouldn't be aware of any multi-cluster knowledge about this mesh. Operator will only take the Istio control plan specs and create those resources and make sure those resources get reconciled if anything modified by customer manually. And can we jump into the next section, the design ideas? Okay, let me see the diagram. The diagram.
Yeah.
So this is what I propose as a recommended deploy model for multi-cluster. And it will show how the multi-cluster command works with the operator. So the diagram, there are two clusters here, just to illustrate how it works. And the first one, the first step is the CI/CD system will give the Istio kernel multi-cluster command topology of the multi-cluster mesh as a mesh YAML. And second, it will give Istio control plane specs YAML as in-cluster resources. The command takes those two inputs and output the combined Istio control plane YAML. Once the multi-cluster when the remote secret and gateways. And the key point here is only this Istio multi-cluster command knows the topology about this multi-cluster mesh. It will generate the manifest for each cluster when the proper remote secret and gateways. And it will pass those Istio control plane YAML to different cluster. And all those manifests may be different because the remote secret are different. And at that point, the CI/CD system passes the manifest to different cluster. The cluster will create the Istio operator. The operator will only take care of the in-cluster resources and start the Istio control plane and other required resources. And that is what I propose today. And can we jump to the next section? The alternative, oops, it gets changed. So another option is the Bonsai Clouds diagram. They have an operator. No, maybe someone modified. Jump to the next one.
This one?
Oh, sorry, I'm running out of time and I need to leave this room. And this is only about calling for comments on this talk. And thank you, guys.
Thanks, guys.
Sorry.
Are we continuing with Tao's presentation, or are we calling it a day? Because I see people are leaving anyway.
I think we can continue if anyone has any feedback on this talk.
So I had a question about how so the multi-mesh doc we saw at the beginning, there's a strong emphasis on the requirements for what we need to do and what we don't need to do. Do we need to do the same thing here in terms of what? There's different models for like pushing config and pulling config, and what gets persisted by CI/CD, what needs to be a ethereal artifact. Do we need to capture those requirements before we get into more final design? Or do we feel confident that we like really understand that?
You mean we need to list out all the pros and cons, what we need to do and what we need not to do in the doc?
Not pros and cons for the design, but what I found with trying to set up a multi-cluster mesh is there's some things about, so this is pretty much what we have in 1.4. there's some nice things about it because you don't need anything in cluster, but it was really easy for me to mess up if I forgot something because there was no controller that was fixing my mistakes. Maybe that's the right thing to do, or maybe people want like a self-healing, some self-healing aspect to this. So I think more things are automatic, maybe in the system, rather than everything being pushed to CI/CD. So it's not clear to me what people actually need or want there.